Hello guys, in this video we're going to do a little exploration. So as you're taking your notes, you can write these questions down, but then what I really want you to do is pause the video each time and think about them before I start answering it myself. Okay, so the first question we're going to think about is, what are the relationships between the coefficients and each parenthesis? Remember, coefficients are the numbers in front of the variables. So I want you to look at 3 and 2 and 9, 6, and 4. Are there any relationships between 3 and any of those or 2 and any of those? So think about that. So at this time, maybe pause the video, write down that question, or you have it written down, but think about the answer to that question. Okay, so for me, what I'm noticing is 3 kind of has to do with these two, and 2 kind of can go into those two numbers. So 3 is divisible into 9 3 times, and 3 can go into 6 2 times, whereas 2 can go into 6 3 times, and 2 can go into 4 2 times. Or another way of saying that, 9 is the same thing as 3 times 3, 6 is the same thing as 3 times 2, and 4 is the same thing as 2 times 2. So, I mean, you know, what if anything, is that signify? If I take 3 and I multiply it by itself, I can get that first coefficient. And if I multiply the 3 and the 2 together, that gives me the middle one. And then if I multiply 2 by itself, then that gives me the last number. So that's kind of cool. All right, so let's actually do step 2. We're going to multiply the polynomials, and let's look at what we get with our coefficients with our answer. Okay, so if I multiply 3x times everything, so I'm going to be doing 3x times 9x squared plus 6x plus 4. So that's going to give me, let's see, 3 times 9 is 27. This will be x cubed. And then I'll have 3 times 6, that's 18. And then that'll be x squared. And then I'm going to have 12x. Then when I distribute the negative 2, I'm going to be doing negative 2 times all of that. I'm going to write this over here. Okay, so that's going to give me, okay, sorry about that. That's going to give me negative 18x squared, then negative 12x, and then minus 8. So now I'm going to combine all of my like terms together. So are there any other x cubes? No, I don't see any, so I'm going to bring that down. And then let's see, what about my x squares? I've got 18x squared minus 18x squared, so those cancel. Well, that's cool. And then I've got 12x and a minus 12x, those cancel as well. That's even better. And then do I have any other constants? No, I don't. So all of that, when I distribute all that out and I combine like terms, this is my final answer. So let's look at these coefficients compared to what we started with. So 27 and 8 compared to the 3x minus 2. Well, and we also had 9x squared plus 6x plus 4. Well, if you notice that it was the 3 times the 9 that gave me the 27, right? Okay, so those two gave me the 27. And then the 2 times the 4 is what gave me the 8. But remember what we said about 9. 9 was the same thing as 3 times 3. So when I did 3 times 9, that's the same as doing 3 times 3 times 3. What's another way of saying that? Yeah, that's like 3 to the 3rd power. Okay, same thing with the 2. All right, we said 4 was the same thing as like doing 2 times itself. All right, so when I do 2 times the 4, 2 times 2 times 2, that's the same thing as 2 squared. So 3 cubed is the same thing as 27, and 2 cubed, should have had a cube there, 2 cubed is the same thing as 8. So when I multiplied those out, I got perfect cube numbers, right? So that's kind of interesting. So let's do the same thing for number 3. All right, so again, if I look at my coefficients, all right, this is a 1, this is a 1. Okay, so if I'm looking at these, all right, 1 times itself gives me 1, right? So this is the same thing as 1 times 1. This is the same thing as 3 times itself, right? Because I'm looking at these coefficients. And then this is the same thing as 1 times 3. Right? So we see that same pattern that we were doing. So let's distribute and see what we get. Okay, so if I distribute, I'm going to be multiplying x times all of those. And then I'm going to be doing 3 times all of those. Okay, so I'm going to get x cubed minus 3x squared plus 9x. Then I'm going to get 3x squared minus 9x plus 27. Combine my like terms. These cancel again. So do these. And all I have left is x cubed plus 27. All right, so again, I'm getting perfect cubes. That 27, again, remember that's 3 to the 3rd power, and this is 1 to the 3rd power. So I'm getting that same answer, kind of answer. So if I had to guess what this one would be, do you notice how this is 1 and this first one is 1? So this is the same thing as 1 times 1. And 16 is the same as 4 times 4. And the middle one is the same thing as 1 times 4. So I'm seeing that same pattern. So if I had to guess what my answer would be when I multiply these out, I would guess that it would be, my final answer would be 1 cubed x to the 3rd power, and then I would have a minus 4 cubed. Okay, so what would that be? 4 cubed would be, let's see, 40 plus 24, so that would be 64. So that would be 1 cubed is 1, x cubed minus 64. I would guess that when I distribute that out, that that's what I would get. Okay? So that's the pattern that I'm trying to see. Okay? Is these cube numbers is recognizing that pattern. So let's see if we can go backwards. Okay? If this was my answer that I got, what did my parentheses look like? Okay, so I want to know what number times itself 3 times gives me 8, and what other number times itself 3 times gives me 1. Well, I know the 1. I know that's 1 times 1 times 1. Okay, what about 8? I think we did that before. 2 times 2 times 2 would give me 8. Okay, so then what does that look like as a parenthesis? Well, if I go backwards, then that first parenthesis was always these numbers that were multiplied by itself 3 times. So I know I would have a 2 in the front and a 1 in the back. And I always had an x there. That's where that x cubed comes from. So I know I have a 2x. And then the question is, would it be a minus or a plus? Well, this ended up being a plus, so I'll guess that that's probably a plus. Okay, and then remember we said in the second parenthesis where there was 3 numbers, this number was always that first number times itself, so like 2 times 2, and then this last number was always the last number times itself, and then in the middle it was always 1 of each, right? So I would guess that this first one would be a 4, the middle number would be a 2, and the last number would be a 1. And then if I go back and look at like the powers and everything, the first one was always an x squared, so I'll put an x squared there. The middle one was always an x, and then the last number was always just a constant. Okay, and then sometimes they were a plus and sometimes they were minus. So I'm going to look for one that had a plus in the beginning. And here's one that had a plus in the beginning. So they had a minus and then a plus. So maybe I'll see if that works. Okay, a minus then a plus. Okay, so that's what we would anticipate would give us the 8x cubed plus 1. And if we wanted to, we could distribute that out and see if we actually get 8x cubed plus 1. Right, but we'll save that for another time. So here's what I want you to put in your notes. What we just discovered and what we talked about was the sum and difference of cubes, that pattern, recognizing that pattern. Okay, so I'm going to put it in general terms. A and B, even though these are variables, these can be any number, any variable, anything that we want it to be. All right, so we can fill in the blank with that. We could put 2, we could put 3x, we could put 1, anything that we want in there. Okay, so if I have a sum of 2 cubes, remember sum means that I'm going to be adding 2 things together, and cubes means that they are both raised to the 3rd power. So if I have a sum of 2 cubes, I know that they are going to factor like this. There's going to be a parenthesis that only has 2 terms, and then another parenthesis that has 3 terms. Okay, so remember how we got that pattern. What will multiply by itself 3 times to give me a cubed? Well, that has to be a times a times a. Right, so that's that first one. Okay, so essentially what we're doing is the cubed root of this. Okay, if I do the cubed root of a cubed, that gets me a. Okay. And then if I do the same thing for the b, the cubed root of b cubed is simply just b. Okay, the cubed root and the cube cancel each other out. Okay, and then if it's the sum of 2 cubes, then this first sign is always the same. Okay, then in the second parenthesis, I'm going to take that a and I'm going to multiply it times itself. So that's going to be a squared. Okay, and the last thing, that b, that will always be multiplied times itself in the last number. And in the middle, I always take one of each. I take a single a and a single b. Okay, and then like I said, the signs, they follow this pattern that I call SOAP. Okay, so the first one we said is always the same. So I'm going to put an S there for same. The second one is always opposite of what the first one was. Okay, so it's always opposite of what we're doing. So here we're doing a sum, so the opposite of sum is minus. Okay, so this is O for opposite. And then the last one is always positive no matter what the original sign was. Okay, so I'm going to put AP for always positive. So if you see, that spells soap. S-O-A-P. Okay, that helps you remember those signs. Okay, so I'm going to do the same thing, but now I'm going to do the difference of cubes. Okay, so the difference means that I'm doing minus in between. But it follows the same pattern. Okay, so I'm going to be doing the cubed root of a cubed, and that gives me a. And I'm going to be doing the cubed root of b cubed, and that'll give me b. So when I do this pattern, I'm going to have a in the front, b in the back. That's in that first parenthesis. In that longer parenthesis, I'm going to have a times itself, b times itself, but that goes in the very end. And in the middle, I have a times b. And then for the signs, use SOAP, right? First one will be the same. So this was a difference of 2 cubes, so it'll be the same as that, so it'll be a minus. The second one is always opposite, so we originally had a minus, so we're going to have a plus. And then the last one's always positive, regardless of what we started with. Alrighty, so that's our sum and difference of cubes patterns. Okay, so that's what we use to factor a sum or difference of cubes. So now that we're talking about factoring, let's list at least 3 methods of factoring. So again, pause the video, see if you can come up with one. All right, so factoring, remember we had GCF. That's when we divided everything in our polynomial by the same thing, what they had in common. We also had difference of two cubes, or I'm sorry, difference of two squares. That's when we square rooted each thing, right? That was like if we had a 4x squared minus a 25, that kind of thing. Okay, and then we also had our just plain old trinomial, what two numbers multiply to give me 4 and add to give me 5, right? So that's just your trinomial. So there's 3. You might have remembered factoring by grouping. And that's when we split up that middle and we grouped the first two and the last two. Remember doing that? And then we did the GCF. So those are 4 ways that we have done so far. All right, so let's kind of refresh our memory with doing some of those. Okay, so in part A, and I'll cover some of these up so we aren't distracted. In part A, let's always check for the greatest common factor. So what can I divide each of these by? Well, no numbers, but I can divide each of these by x. So I'm going to put that x in front, and that leaves me with x squared plus 2x minus 3. And now I'm going to factor that x squared plus 2x minus 3. So what two numbers multiply to give me negative 3, add to give me 2? Okay, so that's going to be, I'm going to keep my x out in front. But instead of a single parenthesis, I'm going to have 2 parentheses. So I'm going to have x plus 3 and x minus 1. That's like what we did in Factor Bingo the other day. Okay, so over here, what can I divide each of these by? I can divide them by 2x. Notice those numbers are all divisible by 2. So I'm going to put my 2x in front. That leaves me with 1x squared minus 5x plus 4. Oh, and that's like my example I was doing. So I'm still going to have my 2x, but I'm going to split up. I'm running out of room. I'm going to put that above it. How about that? So above here, I'm going to put my 2x, and then I'm going to split up the single parenthesis into 2 parentheses. So what two numbers multiply to give me 4, add to give me 5? Well, that's 4 and 1, and they both have to be negative now. Okay, so that's all we're doing, is we're just combining a few methods together. All right, so again, what can I divide each of these by? 3x. So I'm going to have 3x parentheses, x to the third power plus 8. Ooh, what do we do there? That's our new way of doing that. This is a sum of 2 cubes. So this is where we're going to use SOAP. Okay, so reminder, this is like my a cubed. This is like my b cubed. And what do? We're going to take the cubed root of each of them. So the cubed root of x cubed is just x. And the cubed root of 8 is 2. If you don't know that, just use your calculator. All right. I'm going to move that down a little bit to give myself some more room. All right, so we follow that pattern that we discussed. So x is going to be first, and then 2 is going to be second. And then in the big parenthesis, I'm going to have an x squared. I'm going to have a 2 squared, which is 4. And then I'm going to multiply 2 times x in the middle. And then remember, my signs follow SOAP. So it's going to be the same as I started, so plus, opposite, and then always positive. So look at that. We combined a sum of 2 cubes with a greatest common factor. All right, so let's do that again. So I'm going to divide each of these. What can I divide 54 and 16 by? Well, definitely 4. No, not 4. Okay, let's see. How about just 2? Yeah, it's just going to be 2. So I can only divide each of these by 2x, so that means I have 2x in front, and then what that leaves me with is 27x cubed minus 8. Okay, so I only have 2 things in there, and notice that it has a cube on it. So if it has a cube, then we want to see if we can take the cubed root of them. So cubed root of 27x cubed. So again, if you don't know the cube root of 27, use your calculator, but that's 3. And then the cube root of x is just x cubed, is just x. And then if I do the cubed root of 8, remember we said that was 2. Okay? So 3x and 2 are what's going to go in our parentheses into our pattern. Okay, so this is continuing down here. So remember, I'm going to have a short parenthesis and a long parenthesis. And the short one, I'm going to have 3x, and then I'm going to have 2. In the long parenthesis, I'm going to square the 3 and the x. So if I square 3, if I multiply it times itself, that's 9x squared. If I do 2 times itself, that's 4. And in the middle, I'm going to multiply them together, so that's 6x. And then we do our SOAP. So this was originally a minus sign, so I'm going to put minus. That's the same. Opposite is plus, and then the last one is always plus. Okay, so there we go. There's our answer for that one. Isn't that insane how much we can do? All right, so a few more, and then we'll be done, and then we'll practice this a lot more in class. So this has 4 terms, so that's where we want to do the grouping. So here's a good review of factor by grouping. So group the first 2 and the last 2. Divide each of these by what we can divide them by. So this is going to be x squared. That's going to leave me with x minus 4. I can divide each of these. Remember, if the first one's negative, you want to divide by a negative. So I can divide them both by 25. So I'm going to put 25 there. And then it leaves me with x minus 4. And remember, we want those parentheses to match, because that's what we're going to be dividing by next. That's our greatest common factor. So we're going to continue this up here. So since I'm dividing by x minus 4, I'm going to put x minus 4 in front. And then what's left over when I divide those out? Those cancel. I'm left with x squared minus 25. Now this x squared minus 25 is also a difference of 2 squares. So that's when we did the square root of x squared is x, and the square root of 25 is 5. So that's again like what we did in factor bingo. So I'm going to have x plus 5, x minus 5. That's the difference of 2 squares. We'll save this last one for class. All right, so bring this to class. Make sure you have plenty of examples.